All right, guys, here we go with 2.3 in our current book. Again, if at some future point those change, I just want to make sure that the content that's going to be covered here, the concepts, are formulas and problem solving. First of all, let's talk about the definition of a formula, or what a formula is. A formula describes a known relationship of quantities. It's typically expressed in symbols or variables. So for instance, we know that to calculate the area of a square, it's always going to be, or area of a rectangle, it's always going to be, the area is equal to the length times the width. Okay, so this is area is the length times the width. Or for instance, if I want to calculate simple interest, the interest is equal to the principal times the rate times the time. Or if I want to calculate the distance will be equal to the rate times the time. So for instance, if I was going 60 miles an hour and traveled for 3 hours, then the distance would be 60 times 3, which would be 180 miles. Okay, or the circumference is equal to 2 pi r, 2 times pi times the radius, and that would be the circumference, or the distance around the outside of the circle. So several examples there. What I want to do is walk through a couple of how to solve for, if we have a formula that has, several variables, how do we solve for it, and then walk through 2 examples real quick. So in this case, we want to solve for y. That means we're going to isolate y. That means we want to get y all by itself and have its coefficient be 1. So we are going to subtract 2x because it's related through addition and subtraction. Again, we want to get anything away from the variable that we can, first through addition, subtraction, and then through multiplication or division. So here I have a negative 3y, then is going to be equal to a negative 2x plus 18. I'm trying to figure out what y is, not what negative 3y is, so I'm going to divide everything by a negative 3. When I do that, this cancels. Okay, and I can simplify, so I will get that y is going to be equal to 2/3, those negatives cancel, x minus 6. Now this equation here is solved for y, but these equations are the same equation, just written in a different format. They represent the same formula, the same relationship. Okay, it just depends on which variable I want to isolate. So for instance, this is the equation for calculating the area of a trapezoid. So if we had a trapezoid, this would be the big base, this would be the little base, this would be the height. So the way that we're going to calculate the area is 1/2 big B plus little b. So we'll add these together. Yes, these are different variables, they represent different lengths, and that's why they're capital and lowercase. So a letter that has a different case is a different variable. So this one I want to solve for b. Well, the first thing here is I have a denominator, so I'm going to multiply both sides of this equation by 2. When I do that, this 2 will cancel over here, so I will have 2a is equal to b plus b times h. Well, I'm still trying to figure out how to get to little b, but I need to perform all the operations that I can, so I'm going to distribute here. So I'm going to get 2a is equal to big B h plus little b h. Now I'm trying to get this away from little b, so I can subtract the big BH from both sides, and that will give me 2a minus big B little h, and that's going to be equal to BH. Well, h is just like a coefficient, just like here we divided by a negative 3, here I can just divide both sides of the equation by little h. So to isolate little b, or to get little b all by itself, we are going to have that equal to 2a minus bh all over h. Again, this is the same equation as what we started with right here, just in a different format, isolating a different variable. So this is how a formula would work in solving formulas for specific variables.